Okay, we are going to do just a kind of, hopefully this is a relatively straightforward and quick video. There's nothing much to really talk about. This is a very straightforward chip. We're going to look at the 4011 CMOS Nand Gate, which I'm sure there must be like a gazillion videos on this, but I wanna use it for I want to put it somewhere too far away. The little LAM324 project. Just because, and because like I want to use this for something, and I'm sure it's going to come up many times. It's kind of, sorry, I put black felt tip pen on my fingers because I drew some pictures. So we're just going to quickly talk about what this does in the basic sense, and then a couple of little circuits to make that you can use this thing for. And the neat thing about this little IC is that it's actually surprisingly versatile, and you can use it to make lots of different things. In fact, you could probably make an entire computer using just these things, because you can make all the other logic stuff out of these gates. So there's another one called a NOR gate, which is also very flexible like this, but I think this is the one everyone goes for. We will look at that's the 4001. We'll look at that at some point. So I've got a bunch of 4011s here. So just take this away for a second and put it under there. So this is the kind of schematic symbol for it. It's meant to be kind of round here. So this is the AND gate part. So I don't know if I actually drew the pictures for an AND gate. So a gate, remember, just as a reminder, it just takes some values of inputs and supposedly gives an output. There's lots of different electrical characteristics depending on what kind of ICs you're using. So if you're using these CMOS things, go back to my long discussions on 4049s for some stuff about how I understand CMOS stuff. But this is a similar kind of thing, and in fact you can use this in pretty much the same way you use the 4049, as we'll see. And in fact, I'm not going to introduce anything that we haven't done before, in a way that we haven't done really with the 4049. Today, but this is a slightly different way of doing it and a better way of doing it in general. But it takes two inputs. It's a very long way of, very off tangent thing. Two inputs, and it has one output, and in this case here, so you can imagine it as working out the AND operation of these two things. So if this is high and this is high, or if you can imagine if this is true and this is true, then the basic output of an AND gate is going to be true. So an AND gate is only true when both of these things, is only high when both of these things are high, and otherwise it's low. And it's called an AND gate if you imagine them as Boolean things, as true and false. So if they're both, so high means true and low means false. If they're both true, so if something and something is true, then the output is true. But if you say it is round and it is what's the shape? It is, this pen is long and blue. Well, one of those things is wrong, so the statement it is long and blue is wrong. But if I said it was long and green, both those parts of it are true, and so the total statement is true. And in the case here, that's what an AND gate does. The NAND gate just negates that at the end. So if this is true and this is true, then the output is false. Or another way of saying it, if this is high and this is high, the output is low. But if this was low and this was high, the output would be high, and so on and so on and so on. So where you would get with an AND gate a low output, you get a high output, and where you would get with an AND gate a high output, you get a low output. And just writing that out here, so this is input 1, input 2. You could flip them around, it doesn't really matter. It's symmetrical, I suppose you could say. So if you have two lows, the output is high. If you have a low and a high, the output is high. If you have a high and a low, the output is high. So you can see that those things are actually interchangeable. But the last one is, or what you can say is, this entire column can be flipped over there and you get the same kind of pattern. If these both are high, then you get a low. And that's the basics of it. So that's pretty straightforward. But you might think, well, what's the point of this? It's not the kind of thing I think I moved it too far to the side. It's not the kind of thing you actually like use in, like with an AND gate and an OR gate. It seems very well rooted in how we talk in a general sense, right? But I don't think anyone ever says a statement that kind of directly follows a NAND structure, right? And so it seems a little bit more removed from everything. So you might think, what's the point of it? But in fact, you can make lots of different things out of it. I'm just going to give 2 examples for now because they're the simplest ones. But I could make a NOT gate simply by tying the 2 inputs together and then taking the output. So if the input was low, then both the inputs will be low because they're tied together. So if the value here is low, then both of these inputs are low. So the output will be high. And if this value is high, then both these inputs will be high and the value will be low. So just looking back to there, both low, high, both high, low. So you can make a NOT gate out of it, just like that. But you could also make an AND gate out of it by putting 2 of them together. So if you take your NAND, and now it's giving an inverted output from what the AND would get, then all you have to do is put it through another inverter, or another NOT gate, and I'm going to call them inverters. Yeah, makes more sense. It's an inverter, so I'm going to invert the output, and you basically get an AND gate. So if both of these, if you get a low output from this, it's going to be a high output in the end. So in this case, it's just going to flip these around. So these are going to become low, 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 and high, which is an AND gate. So you've made an AND gate. But with one more of these things, you can make an OR gate, and you can make pretty much every single kind of gate you want out of these things. Plus, you can make some other interesting things. And so the thing that we're going to make today, just very quickly, is this thing here, which is like another set and reset flip-flop circuit. So this is kind of like what we did with the 4049. Nobody ever does it with the 4049 because it's kind of more simpler to do it with this thing here, and you don't have to worry about. So my 4049 circuit had a couple of resistors thrown in and diodes on the inputs, and so it was kind of a little bit more involved, but it does work, right? And that's the important thing. And technically, if you're using inputs that I think if you're using inputs from other CMOS chips, you could get 3 reset RS latch things. Got so many names for them. I will call them RS. I keep calling them RS latches. So the RS latches, the reset set latch, you can make 3 of them out of a 4049, but you're only going to be able to get 2 of them out of a 4011 because the 4011 has 4. So it's a quad. I didn't mention this before. It's a quad NAND gate. So it has 4 of these little circuits inside of it. And I'm going to show you from this trusty little book here, because it's the only one I have available right now. That's not true, I've got another one right next to me, but this one is what... I should have used that CMOS book. Actually, we'll use that one, that's a much better one. Because the other one gives away too much that I don't want to say. I want to keep it as a surprise. So there's the hex inverter. So the hex inverter, because it has 6 things, and the 4011, which is down here, is the quad 2 input. So quad, so it means 4. It has 2 input NAND gate. So it's got 4 of these little NAND gates, but we only need 2 to make this little thing. But I'm just saying, if you did a 4049 in a certain circumstance, you could get 1 more of these things out of it. But in general circumstances, you'd only get 2 out of it, so it would be the same as this. And this is more flexible. So this is what we're going to do. I'm going to do it real quick because I've just been rambling about it. And the next video is we're going to put this together with our whatchamacallit, what is it called? Oh, the 4049 thing. Where's a little tiny screwdriver? Alright. Shockingly, I hadn't liked doing this because then I have to put sellotape on it again, otherwise all of them will come out. Alright, please don't all fall out. This is unexciting. It's always important, I think, in videos to have the section where you do this. I'm pretty sure I made that kind of joke before. Yeah, the section where you have to pry sellotape open, because this vicious stuff, sellotape. And I shouldn't call it sellotape, I should call it sticky tape, or adhesive tape, because that's the brand name. And I was just discussing this recently that you shouldn't call it sellotape, but it's a hard habit to break, and it may well be sellotape. Sellotape is a good brand, I have to say. I always feel guilty when I buy the cheaper stuff. Alright, so we're going to put this, I'm going to put it so that the little groove is facing that way. And then we're going to plug the little power thing in. And then we're going to put a little... This is being sitting in a small box and has got crumpled. It's still not going to go in. Oh my goodness, this is not what you wanted to see. Alright. So put that there. Oh, I did find my chip. Oh, where did I put it? Oh, I found the little tool and I put it on this desk. And this desk has a lot of things on it, so I can't actually see where I put it. But I had a leg squisher thing, specifically for making the legs go onto this really well. But I've lost it. Hopefully, it will just go straight on, and we won't have to worry. And it won't go straight on, so that's a bit of a shame. Oh, I should have used this one. This is like an old school one. It's got, you can see it written on the top. It's just sitting right here. Oh well, we're not going to. So let's just quickly do this. So the important thing, of course, is it has to have some kind of power connection. So we will just throw on a couple of those. We'll use an orange one. So looking at this, you know what? I don't think I should have put it on that way. Alright, you've got to be kidding me. Oh, there it is. Alright. Alright. So I do have, I'm going to turn it around so that it matches the way that I can see it in the book. So I'm going to use this little tool, which makes that a lot easier. We're not going to make a mess. Alright, it's going to go that way. How much time have I spent rambling on about this? So we've got 16 minutes. What's the point of watching the video from now on? You're just going to skip to the end. Please don't skip to the end. Learn more about stuff. Okay. Got to get them just the right position. Alright. I think that's okay. Alright. And so that, and these ones here, this is, and most of these gate things, they all follow the same kind of pattern. So in this case here, the positive voltage is going to go into this pin. So I've got it orientated that way, so positive voltage there. If you can't see what I'm doing, which you obviously can't, whoa, I've broken the whole thing. These are not going well, these ones. Maybe it's this little breadboard's had a tough time, I would say, over the years, or over the last year. So I wouldn't expect this one to be too good. But I've actually kind of almost run out of breadboards because I've got all these projects that are just sitting there waiting to be finished. So I want to get the, that's not even lining up. I want to get the LM3241 one out of the way so that I can get those breadboard back. So again, I'm going to do the Pong thing, get that out of the way because I get all those ones back. And I want to finish the silly 74HC595 thing, because there's one point I want to do about that. But anyway, let's just have a look. So that's what the chip looks like. So those are the things, and this is the circuit I want to make. So I'm looking at this. So the first thing I'm going to do though is these two inputs are going to come via, so the way that this thing works, as you'll see, if this is a positive voltage, that will reset the circuit, so this will go high and that will go low. This is the output. The little line over the top means that it's true when it's low as opposed to being true when it's high. I guess that's how you can look at it. But here, if you put a positive voltage here, then this will go high. If a positive voltage here, this goes high, they flip around. So that resets this one sets it to low, and this one sets it to high. So you can ignore this for a second if you want. So the 4049 circuit doesn't have complementary outputs, so this is a nice thing about this one. And that's it. So these things here just take low or high voltages. So we're going to use little buttons. I'm going to put one over here. which is probably a little bit out of the way, but that's okay. I want them like this. So one's going to be the reset, but because they are, what do they see? So literally the perfect things to do this with. Sorry, I need to find some decent pull-up things, and I just had the perfect ones and I've misplaced them, but I'm going to use my friends, the 33k ones. So these are my 33k pull-ups. So where is my input? I'm going to put those there for now. And I shouldn't use those actually, they're the same color as the ones I'm going to use for the chips, but that's okay. Alright, so the first one I'm going to use, how am I going to get this to work? They should both be on the same side. Alright, so that's a very long one. Just checking what I'm doing. Alright, so that's the input to this side here. That's one of the inputs there. And actually, what have I done wrong? And I want to also tie that one. So that input is going to have a pull down resistor. So that's my pull down resistor. So when I'm not pressing the button, it's going to be pulled down. But when I am pressing the button, and I feel like I should have thought that one through a bit more. We're going to try and make it look neat and tidy. But of course now that goes across the top. Of course I could have just moved the button and this would make much more sense. That's too small. Oh, they don't seem to have the size that I want. Really? This is the right size. This will reach. Trying to get to the positive rail. Okay, so that's that side done. And we're going to do a similar kind of thing. So the second one is going to be the next one across. So that one which is facing the other way. So hopefully we can make this pretty symmetrical. That one's going to have a pull down resistor. So this is the input, and then we're going to use another one. Oh, that's what I wanted, the little orange one. We're going to have a connection to the button, and then we're pretty much there. I seem to have managed to somehow put, that didn't go in very well. I think that's gone in, and then we can put, actually we'll use this one again. That one's not the same size. Right. Where's the one that's the same size as that? Okay, here we go. Now I feel like I'm going to lose lots of viewers because this is getting boring. Alright, we've done it. So we've done the two inputs and they're tied down, but when I press the button they'll be pulled up to the high voltage, which is what we want. And now we have to do this crissy-crossy stuff. So what's the best wire to use for that? We'll just use these blue ones. This is where I think it's going to get a bit messy. So the output of this one goes to the input of that one. So maybe that won't be too bad. I don't know what rule. We have to. I think we'll use the yellow length. I feel like I need to use orange, but I don't think I have any oranges ones left. They're all long. So what I'm going to do, well I would do, oh no, uh-oh, oh here it is. It's the one thing I don't think I normally lose on my desk. I'm never going to use these red ones, am I? So I'm just going to cut it up. It's going to be exactly the right length. Nope. The big problem when you use these ones is that they pull the whole wire around. So in my cheapy $2 shop, long nose pliers, These don't line up properly. Alright, so that's one red one. So the output is that one, and then the input, well, that was actually really dumb. Really has to be quite short. Okay. Oh, like super short. Alright, so if you look on the picture, like there, that one there, I want this input to be connected to that output, and then I want that input to be connected to this output. So they're very, very close together. So I kind of feel like I should have used a little tiny one. Maybe I should do a little tiny one. But I kind of feel like if you're going to build a circuit, you should put those bits in first. So the second one here goes to there. That's not quite the right size. In fact, I think I should have used the blue one. And yeah, the blue ones are sweet. Okay, we'll use the blue one for this. The blue ones are the right size. Except I can't. Look at that. That's just perfect. Okay. And so now we've actually done this entire circuit, and now we just have to do something with the outputs, and then we're pretty much done. So I'm going to just use the long wires for the outputs. The long, undoubtedly going to break any minute wires. So that one is the output, and that one is an output. I'm pretty sure that's right. It's a bit hard to tell from this angle. And we just need a couple of LEDs. And I'm going to use my trusty 470 ohm ones. So I was going to try and start using 1000 ohm ones, 1 kilo ohm, because you really are stressing. I feel like, you know, the poor little things, they're not supposed to provide that much current. And these little LEDs, they light up just fine no matter what you do with them. So I don't know where I put the little box for the LED. I'm terribly disorganized today. Well, here we go. Here's a green one and a red one. I mean, it's not like I really have to care. Like they're literally everywhere. They're just creeping around. Those ones look a bit sick, but hold on. Here's another less sick red one. And just so that I don't waste my time, except I'm going to because I've lost it. Oh, there it is. Let's just test these. So I want to get in the habit of always testing these every time. That one works, and I just want the green one to work. And then we can call it quits. What's the time? 5 minutes. We've got just enough time. I can't believe I made this video that long. So alright, so over here we're running out of room to put these things on. So if you heard that beep, that's actually just my phone. And the other thing that I'm going to do, so these circuits are better at, I've read it somewhere, I don't know if it's the CMOS things, it probably is, I'm pretty sure it's the same with, it is with the TTL, but they're better at sinking current than they are at sourcing current. So instead of me taking a positive voltage out of here, but no, I kind of want to do that, don't I? No, I'm not going to do that. So the other way of doing it is that instead of saying you can have a positive voltage coming in here and going into the output, and when this is low, it will sink current because you've got a positive voltage here and it will go into here to a low voltage, and it can sink more current if you do that. Whereas opposed to the other way of doing it is you have this LED connected to ground, and then this has a high voltage, and then the current goes that way. But you can't source as much current in general, I don't think. But I'm going to do that because I know it works fine anyhow. It's not like it's a big deal. For little tiny LEDs, that is. But if you're like, I mean, I just feel like if I'm doing this, I should kind of be doing it as though I was going to make a project that would be on for hours and hours or days and days and days, and I want it to work properly. And not just... So hold on, alright, so I've got them all connected to the long legs of the LEDs, and then I'm going to use these guys. I could just cut the legs off this one and make it a bit shorter because it's a slightly long one. And I'm going to. And I'm just going to hold it there, close my eyes. Because I'm terribly worried that I'm going to one day shoot myself in the eye with one of those. Having shot a kid in the face just last week with a Nerf gun, I feel like I'm primed to... I didn't mean to shoot someone in the face with a Nerf gun. Because I had just been saying don't shoot people in the face with Nerf guns, and then I accidentally shot someone in the face with a Nerf gun. So these things can happen no matter what you're intending to do. They weren't very happy about it, but I'm sure they're forgiving me now. Right, it's not my fault. I'm an incredibly good shot with a Nerf gun, but I didn't actually close my eyes that time or hold it properly. So that's the point, you see. You've got to really be paying attention, and I should really be putting my safety glasses on. If you're doing this at home, please use safety glasses. Please don't lose an eye for no reason at all. But then they look a little bit nicer when they're a bit lower down. The same with the LEDs. I should really cut the legs off the LEDs. But then I'll have to pay attention to which is the anode and which is the cathode. Which is why I don't cut the legs off LEDs. These poor little wires have been well worn recently, so I don't think they're going to work that well. So let's just see if it works. So hopefully when we turn this on, one LED will come on and both of them come on. We did something wrong. They're both on. What if they're both flickering? What if they're... so this is correct, right? You know, it's one of these days that I kind of hope. So you might be thinking, oh yeah, but you've got the buttons close to here and that's what's playing around and you've mucked it up with the buttons, but I don't think I have. But I'm just going to double check. I'm running out of time. I've got 1 minute and something seconds. Well, that would be... I hope I get it to work. So that goes to ground. This goes to the... Well, I know the buttons are fine. That one's pulling it down. They're both pulling it down, otherwise they're being pulled up, so that's fine. The output, oh, it might be the same kind of problem because they're not buffered. Oh, I didn't think about that. I should have, because that was the whole point of the 4049 conundrums. So what we're going to have to do, well, I might have to do this, because I've got the LEDs, that they're probably interfering with the circuit here. So because this is going to create a voltage divider through the LED when this is a positive voltage, so you might not get the voltage you're expecting, though I think you would, wouldn't you? Because that's not going to interfere. If that's a high voltage, you're still going to get a high voltage here because it's branching off that way, and if it's a low voltage, you're still going to get a low voltage. So I don't think that's the problem. So that's not the problem. How much time? 33 seconds. So I don't think I'm going to get this to work, which makes me sad, because maybe I just wasn't paying attention. So that's 1, 2. Alright, I'm going to have a quick look and then I'm going to post a little follow-up video when I worked out why it doesn't work. So thanks for watching, like, share and subscribe, and I can't believe this didn't work. It was the simplest thing of them all. Okay, well, next time. Bye.